10:30.
Ya, itu lupa sangat. Besok I sebenarnya, sekarang ni lecturer tengah ada audit. I kena audit orang pukul 11. 11 sampai pukul 12. So pukul 10.30 ke pukul 11. Sempat ke kita nak buat apa-apa setengah jam tu? I rasa macam tak sempat je yang tu. Pukul 10 tak boleh, pukul 10. Siapa ada kelas pukul 10? Boleh pukul 10. Can we start at 10? Tak ada tak? Aku tak? Saya free tak pukul 10 tu? Saya free pukul 10. So kalau boleh kita start pukul 10. To those yang tak boleh join pukul 10 tu is okay. So basically we will discuss on the tutorial lah. Okay? For the tomorrow class. Alright. Okay. So let's we continue with our class today. Can you see my screen?
Yes, Doktor.
Okay, so last time. Ikut ni. Cuma dia nak hang pagi ni. Kenapa dia tak nak gerak dah I punya ni? What happened? Close app. Okay, what should I do now? Ni. Share, jangan lupa attendance. I tak check attendance kelas ni daripada hari tu. Please dekat in call messages ni, write down your name supaya I boleh, oh no, dekat WhatsApp group to record your attendance. Nanti Dr. Mazlina boleh track record you punya attendance untuk sementara yang dia tak ada ni. Okay, for just your information, Dr. Mazlina akan masuk early May so I can cover kelas ni until week 6. So please what tadi? Attendance dekat WhatsApp group supaya dia boleh record. Okay, jangan letak satu-satu copy one by one. Mana kelas you tadi ni? So seorang start and then continue lah. Sambung daripada yang Raja Ilhan ni. Okay, sambung daripada Raja Ilhan punya attendance ni. Letak nama kelas sekali kalau boleh. I nak buat apa tadi? I nak share option ni. Oh tak, I dah ada. Okay, nampak I punya slide?
Nampak, Madam.
Okay, so hari tu kita stop dekat sini, betul tak? Yang I tergesa-gesa kata you buat yang ni, buat yang tu, am I right? I ask you to study by your own. Betul tak yang ni?
Betul, Doktor.
Dah study dah? Okay, but since that we will have a class tomorrow, but it's okay, I will explain to you about this example, okay? This example is very important for you to understand because it involves with all the equations, all the concept that we have done before. Okay, daripada first section. Okay, from the first section. Okay, you ready? Can we start? Semua orang dah ada? Okay. So, nanti bila masuk kelas fizikal, you all siap I panggil senyap je you all ni Alright. Again. Whenever you want to solve for any kind of engineering problem bukan untuk problem dalam subjek ni je, bukan. Semua. So, bila mana you want to solve for engineering problem, okay, you need to understand the overview of the problem. Okay, get the overview of the problem first. Okay, masalah dia apa ni? Berkaitan dengan apa ni? Okay, contoh for this case. Okay, bila tengok gambar and then you skim the statement. Okay, baca sekejap statement tu, then you should put your first overview on this problem first. Okay. Kalau kita tengok daripada gambar rajah yang diberi, okay, it involves with several body. Ada several body, which is this body can categorize as particles. So kita ada more than one particles. So meaning that this is about the motions of several particles. Okay. We study about motion of several particles. Under several particle, kita tahu dia ada apa? Dia ada independent, dia ada dependent motions. Okay. Kalau independent motion or dependent motion, basically we can study about relative motions. Okay, cumanya independent ini je yang dia boleh study. For dependent, okay, dia boleh study again about the absolute velocity, absolute acceleration, absolute positions. But then before we can study all that quantities, motion quantities, okay, you need to know about the equations that you have to develop. Okay, yang mana untuk dependent motion, you need to start with write the constraint equations. Okay. Under the dependent motion, you need to write constraint equation ataupun position equations. Okay. Ini perbezaan di antara independent and dependent. Yang mana independent and dependent both can study about relative motions. Okay. I hope that you remember what is relative motion all about. And then dependent motion, to solve for this dependent motion, you need to understand that we need to start with write ataupun develop constraint or position equations. Okay. And then on top of that, bila kita study about motion of several particle, dia melibatkan beberapa particle, right? You need to understand that not all particle will undergo the same type of motions. Okay, yang mana untuk setiap particle dia ada beberapa type of motion yang kita dah belajar sebelum ni. Okay, di antaranya kita belajar apa? Motion of particle yang mana kita based on function, yang mana dia punya position, velocity and acceleration itu changes according to time. Okay. Yang mana acceleration itu can change based on time. But if you have another two condition yang mana apabila A equal to 0 and A equal to constant, ataupun kita ada A in term of the tiga condition A is a function of T, A is a function of X, A function of V. Kita ada tiga condition about A ni. Okay. Again, I repeat, when we talk about particles ni dia boleh ada three type of motion. Sama ada there is no accelerations, sama ada dia ada constant acceleration, or dia ada acceleration of function of T, acceleration of function of position, or acceleration of a function of velocity. Okay. Kalau you melibatkan the last part ini, okay, you have no choice. You have to derive the equation for the velocity and acceleration through integrations. Okay, you kena buat integration daripada awal sampai ke sudah untuk menghasilkan equations. Okay, untuk menghasilkan satu function that can be used to calculate the velocity and the position at any time. Okay, but when we are talking about A constant, we can study all the type of velocity, all the position by using three basic kinematic equation. Dia ada tiga basic kinematic equation yang mana you tak perlu nak derive dah. Okay, kita punya center tu dia dah develop for you equation that you can directly implement it into your solutions. Okay, and then another type of motion adalah apabila A is equal to 0. Apabila A to equal to 0, meaning that your velocity is constant. Okay. Sekejap. Okay, I'm sorry. Hari ni anak I nak balik. Dia rasa dia call lah naik bas. First time naik bas daripada Johor. Okay. Alright, so kat mana tadi? Okay, so bila kita nak start to solve the problem, this is something that you have to look at. Okay. Tengok overall. Overall kita study, this is about the motion of several particles. Oh, this is about dependent motion. How do we know? We see this cable. Okay, yang mana the three particles here is connected by cable. Okay, bila dia connected by cable, bermaksud dia melibatkan dependent motions. Okay, then we know that when we talk about dependent motion, you need to develop the constraint or position equations where you can use later on to define the velocity and the acceleration as well. Okay, and then on top of that, we know for this case, dia melibatkan three different particles. Mana setiap particle ni akan involve dengan different type of motions. Okay, as I told you before, dia boleh dalam keadaan A as a function of T, A as a function of X, and A as a function of B. This is one case yang mana if you have this kind of cases, we need to derive the equation for the velocity and the position to solve for that quantity of motions. Yang mana kita kena derive menggunakan kaedah integration. But if you define that, dia kata, oh, particle A moving with constant acceleration. So we go to the second case. When we talk about constant acceleration, you tak perlu nak integrate, you tak perlu nak differentiate. Okay, you just pilih dia ada tiga equation yang dah disenaraikan under A equal to constant. Yang mana kita panggil apabila A to constant, we call this type of motion as uniformly accelerated motion. Okay, and the third case is when you have zero accelerations. When you have zero accelerations, meaning that you have constant velocity. Okay, so this condition meaning that the particle is undergo uniform motion. And again, to solve for the problem for this particle that related to the uniform motion, you tak perlu nak derive any formula. Okay, you can directly the formula that has been developed for you. Okay, so once you clear all about this concept, then you will easily to solve the problem. Okay. Right now, let's look to this example. So for when I'm trying to explain this one, I'm looking feedback from all of you. Okay, so please give me feedback. Okay, answer me when I ask you because I want to check whether you understand or not. Okay. Alright, dia kata apa? Pulley D is attached to a collar which is pulled down at 75 millimeter per second. Pulley D, this is pulley D. Okay, is attached to a collar which attached to a collar which is pulled down. Pull down maksudnya dia tarik ke bawah at 75 millimeter per second. How do I know this is velocity?
Unit.
Unit, yes, good. Dia tak sebut pasal, dia tak mention pun itu velocity. Tapi based on the units, we know that this is about velocity. Okay, and then for the pulley D here, adakah dia ada mention about this is the initial velocity of the pulley equal to 75 millimeter per second, ataupun dia kata at t equal to 0 the pulley is pulled down at 75 millimeter per second. Tak ada mention about initial value ataupun t is equal to 0, ada tak?
No,
So meaning that the velocity ni kita kategorikan sebagai apa?
constant.
Constant, correct. So this is constant velocity. Bila dia constant maksudnya pulley D ni dia undergo what type of motion?
Uniform motion.
Correct. Uniform motion. Okay. Baca lagi. At t equal to 0. Collar A start moving downward from K ni. At K ni t equal to 0. Moving downward with constant accelerations. So kat sini ada A constant. And zero initial velocity. V naught. V naught adalah simbol kepada initial velocity equal to 0 millimeter per second. Okay. And then knowing that velocity of collar A is 300 millimeter as it passes L. Bila dia passes L, bila polar tu berada di L, okay, velocity di sini sama dengan apa? V is equal to 300 millimeter per second. Okay, so kita boleh define tak type of motion for polar A now? Dia undergo motion apa? Polar A?
Uniformly accelerated.
Uniformly accelerated motion. Good. Thank you very much. Okay. So, based on the statement given, then kita dah identify what type of motion involved for particle A and pulley D. Okay, then we continue read. Yang tadi ni semua statement. Ini problem statement. Okay, ini problem statement. Now, this is the question that you need to solve. Alright, the question is, determine the change in elevation, velocity, and acceleration of block B when block A is at L. Okay. So based on the statement here, overall statement, tadi kata apa? A, dia kata dia nak change in elevation, velocity, and acceleration of block B when block A is at L. So bila A ke L, you rasa B ni bergerak ke mana? You rasa-rasa. Ini kedudukan dia dekat T equal to 0. Okay. So bila A ke bawah, what happen to B? Okay, dia akan secara keseluruhannya kita akan nampak dia akan bergerak ke atas. So, this is at T equal to certain time lah. Alright, apabila K tu berada di L. Okay, so this is the final position for block B. Okay, this is the final position for the block B. Okay, itu adalah di antara kerja-kerja yang you buat. Whatever yang I'm doing right now, that is the thing that you have to do in your solutions. Get the you have to illustrate it. You make a sketch first. Dapatkan dia punya gambaran. What is given and what is required, okay, and what need to be solved. Okay? So based on here, for the first question, determine the change in elevation. Maksudnya dia nak apa? Apa yang dia nak? Position apa? Final position or initial position? Final position. Change in elevations. Macam mana dia punya mathematical form dia?
Final kalau initial.
Final minus initial. Ini yang dikatakan dengan change in elevations. Okay, YB minus YB not. You kena dapatkan jawapan ini. Jawapan hasil daripada YB minus YB not ni. YB ini YB minus dengan YB not. Ini yang dia nak. Aduh, sekejap. Okay. Boleh dengar ke suara I?
Boleh.
Okay. Alright, the next question asks you about velocity. So this one very straightforward lah. Determine VB and then the last one is AB. Okay. So ini adalah benda, again, something that you have to give first. Nampak kan? Tunjuk apa yang benda yang you nak kena cari. Oh, AB, VB. Sebab kadang-kadang orang boleh visualizekan based on this symbol. Okay? Alright, so this is the overall data that we can provide, okay, that we can give to ourselves, okay, to direct us to the solutions, okay. So from here, we need to get the change in elevations. Itu soalan dia. And dia punya overall problem melibatkan motions, dependent motions of several particles. Okay, as we discussed before, when we talk about the motions, dependent motion of several particles, normally we need to start with derive the constraint or the position equations. Okay, kalau you go through dengan example ni, okay, dia sebenarnya tak boleh start dengan solution yang ini. You tak tahu kenapa tiba-tiba boleh kena start dengan cari VA. No. Actually, dia start dengan what is the main equation that need to be used to solve for the first problem. First problem melibatkan the positions. Yang mana is come from the position equation actually. Okay, so kalau ikut procedure for the dependent motion equation, this is the first step where you need to derive the constraint or dependent motion equations. Okay, all right. So to write these equations, you must have this diagram first. This is a must, wajib. Okay, kalau lah ada keluar soalan test ataupun exam nanti, untuk gambar rajah saja dah ada 2 markah ataupun 1 markah. Okay, so how can we draw this diagram? First, we start with what? Find the fixed datum line. Find the fixed datum line. So I select here. So this is my fixed datum line. Okay. And then show your positive coordinate axis. Yang mana I assume downward is positive. Kenapa I assume downward positive? Kenapa tak upward? Sebab everything I kena measure from top to bottom. I kena measure position from top to bottom. Okay. That's why I choose the coordinate axis downward is positive. Then next, I find the position coordinate for each particle. I ada particle A, so I ada XA. I ada particle D, so I ada XD. And then I ada particle B, so I ada XB. Okay. So done untuk gambar rajah ni. Ada masalah? Siapa yang ada masalah untuk draw this diagram? Siapa ada masalah untuk lukis gambar ni? Semua okay? Alright. Okay. So now once we have this diagram, then we can proceed to write the equations. Okay, kita nak write equation tu apa dia punya konsep dia? Konsep dia kita nak kira total length of this chord. Total length of this chord. Okay, kita ada berapa segmen dia? Kita 1, 2, 3, 4. Ada 4 segmen. Macam mana kita dapatkan length untuk setiap segmen ni? So length untuk setiap segmen ni kita akan refer kepada position yang kita ada kat sini. Okay. So here for this segment, the length can be represented by XA. So ada berapa kabel on this segment? Ada 1 sahaja. So we will have XA. And then for the second segment, kita ada 2 length yang sama. Yang mana length for this segment can be represented by XD. So we have 2XD. And then the last one, kita ada segmen ni yang attach dengan cola B. Yang mana the length for this cable is can be represented by XB. So we have single XB. Alright. And then supposedly what I have shown to you before should be equal to constant. Patutnya dia must be equal to constant kalau you nak dapatkan velocity for the next question. Okay, kalau dapatkan velocity, you should equal to constant. Okay, but for this problem, since they ask you about to determine the change in elevations, okay, the change in elevation, so then instead of we write as constant, we rewrite again what we have, whatever that we have on the left hand side here to the right hand side, but we provide this initial term. Okay, kenapa boleh sama sebab total length on the left and on the right sama. Dia masih sama walaupun asalnya dia berada di initial, bila dia berubah kedudukan, total length for the cable still remain the same. Okay. Alright, so from here what should we do? Sebab tadi kita dah dapat bayangan apa jawapan yang perlu kita berikan, betul tak? Kita kata to get the first answer is based on XB minus XB naught. So we rearrange this equation until we can express like this. Okay. And then from here, okay, kita dah dapat lah equation yang kita nak tu. So ini yang kita nak, kita dah dapatkan jawapan. Jawapan dia adalah hasil daripada calculation from these equations. So meaning that you should have value for XA minus XA naught. You also should have value for XD minus XD naught. Okay. Alright, so now next step is what? Bila for this case, as you can see, kita ada 3 variable. Kita ada variable A, D and B. Okay, so dalam 3 variable ni, 2 tu adalah degree of freedom. So meaning that it must be known value. Okay, dia mesti known value. Okay, value yang dah kena tahu. Sebab soalan dia adalah untuk B. So value untuk XA minus XA naught dengan XD minus XD naught mesti ada. Okay, so now berapa XA minus XA naught? Kalau kita tengok daripada problem ni, diberi ke tidak? Look from here. Okay, you can see here. Ini adalah untuk kola A. XA minus XA naught maksudnya adalah untuk kola A. Yang mana kita ada, this is the position of XA naught. And then this is the position of XA. So XA minus XA naught is equal to what? Equal to 200. So we substitute 200 here. Okay. And then we need to define for XD minus XD naught. Okay, now this is diagram for XD, XD naught. If you look from the original diagram, you cannot see any distance here. Alright, there's no position or distance shown in this diagram. Okay, so meaning that here, macam I cakap tadi, as I said before, we should have this value, right? We should have this value, but we are not given directly in this problem. Okay, we are not given directly in this problem, but we can calculate this value by using any kinematic equation involved for that particular particle. Okay, so for this one, dia nak XD minus XD naught, right? So meaning that we have to focus on pulley D. Okay, so pulley D, as we discussed before, is undergo uniform motions. Okay, undergo uniform motion. Ini yang kita nak. Ini adalah XD minus XD naught. Okay, so pulley D, dia undergo uniform motion. Yang mana under uniform motion, we only have one equation, one kinematic equation that can be used, which is this one. X is equal to X naught plus VT. Okay, X is equal to X naught plus VT. Alright, so from here, we rearrange it until we can get these expressions. Kita kena dapatkan expressions ni. So macam mana? We bring SD naught from the right hand side to the left hand side. So then we develop this term. Okay, so we already developed this term. We got XD minus XD naught. So kita ada XD minus XD naught equal to VD multiply with T. Okay, so kita dah dapat dah apa yang kita nak. Okay, now meaning that kita can get the value for XD minus XD naught to be substituted into here. Okay, so in order to get this value, what should you have? You should have VD. Ada? Kita diberi VD equal to 75 mm per second. Then you need to have T. At this moment, we don't have T. Okay, yang you tengok ni sebenarnya dah kira sebelum ni. Okay, sebenarnya ni adalah T. At this moment, we don't have T value. Okay, so meaning that we still cannot get the answer of 100 ni. Okay, so kita tak boleh lagi dapat jawapan untuk xd minus xd naught because we don't have t value. So meaning that we have to calculate t value. Okay, you jangan bila buat solution, tak adalah benda ni, tak boleh solve. No. Okay, you have to think more. Oh, macam mana nak cari t ni pula? So this t value can be calculated by using based on condition of polar A. Because this is about connected member, right? Okay. So when they fully move, A pun move lah, alright, at the same time. So kalau kita kata dah tak boleh nak cari T tu menggunakan apa-apa equation daripada puli D, then we move on to polar A. So based on polar A, okay, we are expecting that we can get the T value. Okay, under polar A, we know that it undergo uniformly accelerated motion where it have 3 kinematic equation. This is the first one. The second one is x is equal to x naught plus v naught t plus half a t squared. This is the second one. And this is the third one. Okay. So, in order to determine t, which equation yang kita nak guna? So, kita ada 2 options. Either you can use the second equation or first equations. Okay, dua-dua boleh guna untuk nak carikan t in this case. Okay, so you pilihlah salah satu. So, nampak yang paling simple adalah the first equations. Okay, for the first equation. So, taking first equation, okay, then you can get the t value. Okay, so from here, kalau kita tengok apa yang kita nak, kita perlukan VA. Kita ada VA, diberi VA kita 300. Then you are required to have initial velocity. Kita diberi initial velocity equal to 0. And then, kita diberi A tak? In this case, dia just mention A tu adalah constant. Tapi tak diberi value. So, again, still lagi tak boleh dapatkan T value ni. Okay, tadi isu dia tak dapat nak cari yang ini. Isu pertama dia sebenarnya nak cari this one. Okay, nak cari ni tak ada T. Bila nak cari T, A pula tak ada. Kalau you guna yang ini pun case yang sama. A juga yang tak ada. So meaning that to answer for T here, you need to get A first. How can we get A? So again, this is under polar A kan. Polar A dia ada 3 kinematic equation. So you can choose another equation to solve for A. So tadi 2 dengan 1 dah tak boleh dah. Dia hanya untuk T. So you can use the third equation. So from this third equation, is it possible to get A? It is possible. Yang mana kita ada VA, kita ada VA naught, kita ada XA minus XA naught. So then, we can calculate the acceleration value for polar A. Okay. Di situlah puncanya keluar solution yang pertama ni. Okay, to get the acceleration value for polar A. Alright. Once you get this acceleration value, then we go back balik kepada solution equation yang kita dah keluarkan tadi. Dapat A, ganti masuk dalam ni, dapatlah T. Dah dapat T, we go back to here, we substitute into here, then we get XD minus XD naught. Okay, so this value we substitute into here to get the answer for the first question. Okay, any question for the first question? Ada soalan for the first question here? Yes, betul. Bila A tu bergerak ke B, A daripada K ke L, dia bergerak pada T yang sama lah. L tu, bila sampai dekat L tu, T untuk semua tu sama. Faham? Sebab dia connected kan? Betul tak dia bergerak? Dia connected. A bergerak, semua bergerak. A stop, semua stop. Okay, lain? Can you see here? Nampak tak? Dia relatekan semua yang kita dah belajar sebelum ni. Okay, and then dia try to highlight yang mana you tak boleh bila you kata, oh tak ada pun T, tak boleh nak solve. No. You have to think about, oh, equation apa lagi yang kita boleh guna untuk dapatkan T? Oh, tak ada pula A. A pula tak ada. So, apa yang kita boleh guna untuk dapatkan A? Kalau you rasa dah tak ada apa-apa equation langsung, baru kita boleh kata solusi problem tu ada masalah lah. It has an issue lah. Okay. Alright, so next question, kalau tak ada soalan, dia nak dapatkan velocity at B. Okay, so to get the velocity at B here, we need to differentiate the position equation that has been developed at the first step tadi. Okay, first step tadi kita develop kan equation yang ini. This one. Tetapi kita equipkan dengan initial positions value. But to get the velocity equation, we make it this one equal to constant. Then we write dx over dt. Ini tolong tulis dx over dt terhasil lah VA plus 2VD plus VB equal to 0. Okay. So when come to this part, dah tak ada masalah dah. It's very simple. Okay, we just substitute all the given value or the calculated value. Okay. So we are given VA 300, we are given VD 75, then we can get the VB value. But you have to be careful kat sini, sepatutnya dia get negative. Okay, the answer should be negative value. Okay, dia bergerak ke atas kan. So bila bergerak ke atas, nilai dia mesti negative. Sebab kita assume downward is positive. Okay. And then finally to get the acceleration, we substitute like kita differentiate the velocity function or equations. Then you will get the acceleration equations here. Okay. So we have AA plus 2AD plus AB equal to 0. So masukkan nilai AA, kita tadi tak diberi AA tapi kita dah kira yang mana kita dapat 2 to 5 mm per second square. And how about AD? 2AD berapa? AD berapa nilai AD kita dalam kes ni? Apa nilai AD?
Zero.
Kosong sebab kita punya velocity constant. So then kita dapatlah nilai AB. Okay, clear? Ada soalan? Ada soalan for this one? Clear ke?
So far no question.
Alright, so now kita tengok kepada the last example here. Alright, for the last example, this is not very complicated problem. Nampak je macam complicated but it is not. Okay. So here we have slider block A. Again kita practice ourselves. Kita tengok, oh ada lebih daripada satu particle. So this is about motion of several particles. Okay. Oh ada kabel. Oh ni dependent motion. Okay. So this is how you monitor yourself lah. Okay, this is about dependent motion. Then we know that for dependent motion, you should write the constraint equation or position equations. Okay, so what is the problem that we have to solve here? Okay, so we want to solve for determine the velocity of block B. So we are given statement, slider block A move to the left with a constant velocity of 6 meter per second. Slider block A move to the left with constant velocity. V constant VA sahajalah equal to 6 meter per second. Positive or negative, it depends on your assumption for your coordinate axis. Okay. Alright, so determine the velocity of block B. So you need to get VB value. Okay, so based on this statement, kita tahu ini adalah uniform motions. Okay, so this dependent motion. So you can draw a diagram first. You have to make a sketch first. Okay. Dapatkan datum to find the distance for the position coordinate for particle A, and then datum to find the position coordinate B. Kenapa I tak ambil dekat sini? Kenapa I ambil kat sini? Because we know that this one adalah constant. Okay, that's why I put here as a datum. Okay, so I assume to the left positive, downward positive. Okay, So I have XA and I have XB. All right, so when I have this diagram, then I can write the equations here. Okay, I can write the equations here. So this is a diagram that you must draw. Okay, this diagram that you must draw. Okay, all right. Once you have this diagram, then we develop the constraint equations. Okay, where first we check from here, we have only single segment here. So we have XA, and at this part we have 1, 2, 3, three length. Okay, same length, which is equivalent to YB. So we have 3 YB, and then plus constant. We have constant length here. We put constant. This is the total length. Total length for this cable. Okay. So when we have this, we differentiate. Letaklah dx over dt ataupun ds over dt. Differentiate XA dapat apa? Differentiate XA, you get VA. Differentiate 3YB, you get 3VB. Differentiate constant 0, differentiate L 0. Okay, so substitute all the given value. We are given VA equal to 6 meter per second, positive or negative. Since that we assume to the left is positive, so meaning that this is positive. Okay, 6 meter per second. And then finally you can get the velocity value where your velocity should be negative lah. Negative 6 over 3, which is negative 2 meter per second. So this negative sign show that the velocity for particle B is moving upward. Okay, is moving upward. So negative positive sign is really means to your solutions. Okay, nak menunjukkan betul ke tak. Is it betul you perlu ada negative value ataupun tidak. Okay, so jangan kata jawapan ni salah, dia tak salah. Okay, dia dah sebab dia dah letak magnitude and direction. Yang ni pun betul juga, adanya direction, adanya magnitude. Okay, alright. Any question for this?
No question.
Okay, if you have no question, now ada masa 5 minit je lagi. Okay, so I want for tomorrow class. Okay, for tomorrow class, you need to solve for question 11.51, 11.51. Okay, and then for your homework during your holiday is 11.56. Okay, yang mana I akan explain little bit on how can you solve it. Alright. Okay, so this is for tomorrow punya discussion. 11.51. And then for your homework, 11.56, 11.59, and past year question. Okay, so please take note. Alright. So now let's redo this one, attention quiz, before we end our session today. Determine the speed of block B when block A is moving down at 6 meter per second while block C is moving down at 18 meter per second. Mana? Berapa? 1 minute. As I help you to draw. This one ada datum, ada XA, ada XB, ada XC. Okay, apa equation kita ada kat sini? Tell me. Constraint equation you. Apa yang kita ada? Tu je. Je. XA plus
XA
XB
plus 2XB plus
2XB, correct. Plus XC equal to? Equal to what?
total.
N.
Equal to L, total length. Okay. So, kita dapatkan velocity, kena buat apa? Differentiate dx over dt. Differentiate XA, VA, differentiate XB, 2VB plus VC equal to what? Differentiate L, kita dapat 0. So, VA kita ada 6. VB kita ada 18. So, VC you berapa?
BC
24.
18 minit.
Ha?
12.
Bukan BB, BC
18.
BC yang 18, sorry. BC yang 18. So BB
12.
berapa? 12. Okay, so simple je kan? Very easy, right? Okay, susah tak? Senang je kan? Is it difficult to solve for this kind of problem? No.
Oh.
Is it? Okay, yang ni macam pula. Determine the velocity vector of block A when block B is moving downward with a speed of 10 meter per second. Nampak tak? Velocity vector. Maksudnya kena ada magnitude and direction. Because of what? Because now your problem involved in what? This one. Adanya yang ni it takes some time sikit. Okay. So I can leave it to you. Okay. To solve it. So tomorrow kita akan discuss 2 question lah. Question number 2 and question 11.51. Okay. You must show the detailed solution for both question. Alright. Alright. So any question before we end our session today?
Madam nak tanya yang 11.51 tu,
Hmm.
maksud portion C of the table tu
Maksudnya apa? Dapatkan
saya nak
sampai sini je.
Oh. Okay.
Okay. Lain? Ada soalan? Ada soalan? Tak ada? Okay, kalau tak ada, I think that's all for today. Thank you very much. Okay, so see you tomorrow at 10. Okay, at 10. Alright, to those yang tak boleh join at 10, you can boleh join lepas you habis kelas lah. Okay, so basically kita akan discuss on the tutorial question. Jangan ada tak datang pula bila saya cakap yang lambat tu tetap lewat pun tak apa. Okay. Alright, see you. Bye-bye. Assalamualaikum.
Assalam. Thank you, madam.
Waalaikumsalam. Thank you, madam.
Madam.